I'm ready.
Okay. Previously on what is probability? Okay. So in probability, we start out with a population, like the population of America or the population of New York State. Yes? Or the population of a school. And I started to look at the population of families with kids in Pennsylvania.
Why Pennsylvania?
It was a random state. It felt random to me.
Okay.
Also, I really jacked up the average of kids and blamed it on the Amish.
Okay.
Yeah.
You got population Pennsylvania. You got some literary techniques going there. I like it.
There you go. Very alliterative. All right. Now the parameters are what we are measuring. So we've got families with kids in Pennsylvania. I want the average number of kids in Pennsylvania. Like the average per family, what's the average number of kids that people have?
Okay.
Okay? But Pennsylvania is a big place, so I take a sample.
Okay.
So I take a small chunk of those people, and I measure the sample. Those are called statistics. And so here's my sample. As you can see, there's a lot of kids.
Some of those families have 10 kids.
Yeah.
Somebody should have stopped that from happening.
Yeah. Yes. Austin also said that some sex education was desperately needed in my imaginary Pennsylvania.
Yeah. Yep. I think that's a true statement.
Definitely a true statement. Okay. So then we do some calculations on it to figure out like what the average kid is. Yes?
Yes.
And we can also then make a nice box and whisker plot, which is Squirrel's favorite plot. Where's Squirrely? There's Squirrely. Squirrely, you gonna come see your box and whisker plot? That was a resounding no. Okay. Well, you could come. You could come up here and watch this. You're the one who's not. Sometimes I just randomly talk to Squirrel. It's a thing. Okay. And then hopefully the average that we got will translate to the average number of kids per family in Pennsylvania. So that will help us inform, like, do we need to build more schools, libraries, toy and electronic stores, community activities, all that good stuff. So, do we understand what happened?
We do. I think Squirrel is a believer that you should be measuring the number of cats in Pennsylvania.
I believe that is what she wants. She would prefer the number of kitty cats, as Squirrel is a kitty cat. A decapitated kitty cat currently, but a kitty cat nonetheless. All right. What is probability? Episode 8, bivariate statistics. Yeah, last time we did univariate statistics. Do you remember that, Squirrel? No says no.
Bivariate sounds like something you should take medicine for.
Right? You definitely should. Illustrated and narrated by Izzo. And also Mama Izzo. Mama Izzo, say hi.
Hi.
Awesome. Okay, so bivariate statistics, we still have that population, right? And now we're going to do plants in Grandma's garden. Because that's another thing that I can completely make up. And hey, look, we've got plants as our background.
Nice.
Right? Very good. Squirrely, you ready? Squirrel's unsure. Okay, so the parameters, what we want to know about the plants in Grandma's garden, we want to know the average growth rate. So we want to know how they are growing, which means there are 2 variables. Bivariate means dos variables, because we need to know the height. We also need to know the time it was that height. So we take a sample, because there are a lot of flowers in Grandma's garden.
Just wait.
Waiting.
Isn't it also then going to be dependent on the type of plant?
Would also be dependent on the type of plant.
So don't we have trivariate statistics going on here?
So yeah, that would be dangerous. So when you take the sample, you should be more clear on the population. So you do not want just the plants in Grandma's garden, because Grandma has tomatoes and daffodils and a whole lot of other names I can't pronounce. So we're gonna say, what plant do you want to measure, Squirrel? Squirrel is unsure. Do you want to vote on a plant?
Pole beans.
The pole beans. Okay, the pole beans. So we are only looking at the pole beans. Yeah, you have to be very specific on the population, otherwise your sample can be very bad. Or sometimes you can have multiple things in the population, but then you need your sample to have a representative of each. So if you have pole beans and tomato plants in your population, you got to make sure that there's equal pole beans and tomato plants in your sample, so that your sample is representative of the entire population.
Okay.
Okay. And then we're going to do statistics on that sample. We're going to figure out what's happening with that sample. So we start with, this is the time in day and the height in inches. And they get up to 6 inches.
They're not very tall pole beans.
Yeah, Squirrel is very concerned about these pole beans.
I think we should have picked a different plant.
I think we should have picked a different plant, so does Squirrel. Yeah, 6 inches is a very small pole bean. You want tulips or daffodils? Either one of those would work. Okay, we can do both. Yes, they are both basically the same size. I would agree with you. Okay, so then what we do is we have a graph. Do we see the graph?
The graph.
Beautiful graph. And this is called a scatter plot because all of the dots are scattered on the plot. Yes, it is a very complicated name, Squirrel. These mathematicians, they make stuff up. They do. They make stuff up. So the day is going to be on, whoa, that was weird. Day is going to be on the x-axis. That would be our horizontal axis. Height is going to be on that vertical axis. And of course, we got a title, Grandma's Garden. And you do not connect the points. You can't connect the points. Now, you can figure out a general way that the points are connected. So this is just a scatter plot. Scatter plots do not have lines connecting all the dots. That does not happen. I know you don't like it, Squirrel, but that's how it works. But we can draw a line that's sort of like going through the data. Do we see the line sort of going through the data?
I see the line.
Yeah, that's called a regression line. And that regression line is extremely helpful because it shows us approximately what's happening. So we noticed that on day 1, it was 2 inches tall, but on day 2, it was 1 inch tall. So some rain came, it might be drooping a little bit. Yes, Squirrel, if you got rained on, you would droop too. Yes, I've seen you get rained on. You were very droopy. Yes, you were. You were droopy. Also dopey. So, although there is variation, we can get approximately what is happening. Yes?
Yes.
Okay. And so, using this statistics on our sample, we can assume what's happening with the rest of the population in Grandma's garden. So if she has a whole field of tulips, and we took a sample of the tulips and registered their height and time of day, we could get approximately what's happening. Okay. So this is bivariate statistics. Bivariate statistics is absolutely useless for Grandma's garden. Can we agree on that?
Yes.
Absolutely useless. Grandma is not going to do these statistics. However, they are used for the doctor's office. Yes, the vet's office too. Do you remember when you got weighed last? Yeah, Squirrel, you remember when you got weighed? How heavy were you? 12 pounds ish? 8 pounds? I'm sorry. I'm not going to fat shame you.
She's not
And
that
she's not. I'm thinking 8 pounds.
because I know how heavy Orzo is, and she's nowhere near.
She is nowhere near as heavy as Orzo is. She's mostly fluff. But the height and weight for kids at the doctor's office, that would be a prime use of bivariate statistics. That chart is bivariate statistics, and they use that pretty regularly. Television shows, episode versus ratings. So if you ever hear about actors talking about ratings and how important ratings are, that's because they do a whole bunch of bivariate statistics on that. Whoa, squirrel. Honey. I'm sorry. Squirrel almost tried to eat my computer. And me. Yeah, it was dangerous. She's okay, though. Okay. Month versus billable income. And then we have sports, game versus number of points for players. And farms, chicken versus egg production. Which came first, the chicken or the egg? Any idea? Squirrel is unsure. She just knows she likes chicken. And then we have the zombie apocalypse, day versus infected. All very, very important. Yes?
Yep.
Okay, so these are where we would actually be using statistics. So let's go to this beautiful thing. We've got a trainer, and this is a trainer in basketball, and the sessions that a trainer has with a person and how many baskets in a row they can shoot. Okay? And this is the data. So each of these data points are people, and some people are only on their second session with this trainer. And some people are up there on their 10th session with this trainer. And as you notice, they tend to be making more baskets the more they train with this trainer.
That's how it's supposed to work, right?
That is hopefully how it's supposed to work. That is hopefully what should happen. Okay, and then we've got this beautiful regression line going through everything. Yes? Looks gorgeous.
How do you know where to put the regression line?
That is a great question.
Thanks.
That is a beautiful question. The regression line, you don't just slap it on the graph. It looks like I just slapped it on the graph, so it sort of looked good.
Yeah, it does.
It really does. That's not how you do it. You have to use your calculator.
Oh,
Yeah. It's going to be awkward if you don't have a calculator.
okay.
But that's okay. I will show you how to do it. And led up to it perfectly. Does it look like I am a vampire? I feel like my skin is very white.
Yeah, you look a little washed out, but you're so small in the picture that it doesn't really matter.
Okay, good.
Really, we're not looking at you. You're just
You should not be looking at me. That's a true statement.
you're a little picture up in the corner there. You're not really.
I'm not the star of the show. The math is. Are you playing Bejeweled?
No, I'm not, as a matter of fact.
Oh, good. The shock. I wonder how many of my students are.
I am not playing Vigil. I am reading my email right now.
What?
We're in between things.
We are. Okay. All right, we ready?
I'm ready.
Okay, so this is what the calculator looks like. Beautiful calculator, yes?
That is not what my calculator looks like.
That is not what your you have a 4-function calculator.
Does it have that many functions?
Add, subtract, multiply, and divide. I hope it has all 4.
Here, let me see. 1, 2, 3. Yep, it's got 4.
Got 4 functions, okay. This one's a graphing calculator, it's different.
I can do some square rooty things too, and
Oh.
some I don't know, what's that 1 over x thing?
Inverse?
I don't know.
Inverse functions. It's exciting.
Yeah,
All right.
It's a very impressive calculator.
That is a very impressive calculator. Okay, so we're in the graphing calculator.
Yes.
You're going to go to New Document.
Okay.
And then we're going to go down to Add Lists and Spreadsheets. And we're going to do this exactly like we would be doing Excel.
Okay.
You have Excel, right?
I know how to use Excel.
You actually use Excel a lot in your work.
I do actually use Excel quite a bit.
Okay. So I'm going to type in the Grandma's Garden example. So 1, 2, 3, 4, 5, 6, 7 days is how long we tracked Grandma's Garden. It was 2 inches, 1 inch, 3, 4, 5, 7, 6. Okay?
Yep.
So I typed it in just like I would type in for an Excel.
Mm-hmm.
And I'm going to come up here because we have to label our columns. Just like in Excel, you want all of your columns to be labeled, otherwise it doesn't mean anything. In this case, I'm just going to label it A and B.
That seems boring.
It does seem boring. But on the real chart, it was actually labeled. It was labeled day and height.
Yep.
I feel like that was what it was labeled. Okay. Now, what we can do with this is we can go menu, statistics, statistics calculations, and we've got a whole bunch of information here. There's a lot of things that we can do. The 2 variable statistics, because remember we are doing bivariate statistics today. 2 variable statistics, not actually what you want. I know. I led you astray on that one. You don't want that one. No, you don't want the 2 variable statistics, even though we're doing 2 variable statistics, Squirrel. I know. It's very tricky. You want the linear regression. Do you remember me calling it a regression line, Squirrely? Yeah.
Which regret? How do I know which linear regression?
Good news, doesn't matter which.
Oh.
I like the y equals mx plus b because that's how I learned linear regressions, y equals mx plus b, but it really doesn't matter. You'll get the same numbers either way.
Cool.
I'm going to do linear regression, and the x list I labeled A, and the y list I labeled B. And I want to put this into D. Okay.
What's wrong with C?
I don't know.
We have against C.
We could do C. Probably should have done C because C was like right there. So A and B are still there, my 2 columns. And if I scroll over, it'll say y equals mx plus b. It'll tell me my slope, and it'll tell me my y-intercept. And then it'll say stuff with R, and we're going to talk about R later. That's next episode. Okay, there's another way that we could do this, though. And there's a better way. You ready? We're gonna add a page to this document. So we're gonna do Control Document to add a page. We're gonna add data and statistics to it. Now, if you notice, we almost have a scatter plot, right?
Mm-hmm.
But that scatter plot does not look like the scatter plot that I had for Grandma's. If you notice, that's because my variables aren't in there. It doesn't know where to put the variables. So we're going to put A right here. And I'm going to put B over here. And now it looks like my scatter plot. Magic of magics. Scatter plot done. And then I could do menu, analyze, and I could do regression, show linear regression. And there we go. Y equals mx plus b. Y equals 0.928571 x plus 0.25714. So on day 0, before Grandma does anything, the plant should be about at 0.28 inches tall. So about 1/4 of an inch tall. That's about a seed. I'd say that's right. Maybe. And then each day they grow almost 1 inch. So now I just showed you how to use the calculator. Are you still alive?
I'm here.
You are here. Awesome.
Right here.
Beautiful. We haven't gotten rid of her yet. Mama Izzo is still intact.
Yep.
Wonderful. Okay. So what we need to do is, if you noticed, put this down here. Move my window with you in it. We've got the equation y equals 0.79x plus 1.88. that is the equation for this regression line. Now, we did the equation for the other regression line, but you can just trust me. This is what this regression line would turn out to be.
You say so.
Yep, you just have to trust me. Now, this is the y-intercept. The y-intercept means at the start. So at the start, before any sessions with this trainer, a person should be able to shoot about 2 or 1.88 baskets in a row. So if you notice, that's way down at the left end of the graph. Do we see this arrow right there?
Got it.
That's where it hits the y-axis. So at 0 sessions, we should be almost at 2 baskets in a row.
So am I a failure if I can't make any baskets?
I cannot make any baskets either,
Okay.
let alone in a row. So this trainer would have its work cut out for him.
Me, yep.
It
That
would
would
not go well. It would not go
We
well.
should make sure we have separate trainers, otherwise we will discourage them.
We would very much discourage this trainer because he has like a pretty good track record too.
Yeah.
I
Yeah.
would ruin it.
He should not have both of us.
Should not. That would totally tank his statistics. Poor guy. Okay. And then we've got the slope. The slope is the rate. So for each 1 session with this trainer, a person should improve by a little under 1 baskets. So the rate is actually 0.79. So if you notice, it doesn't go up a full 1 basket. It takes about 2 sessions to go up a full basket. Does that make sense?
Yes.
Okay. So that's on average how many baskets they start with, and on average how much they improve each session. Now, does everyone improve by that much each session? That would be a hardcore no.
Yep.
All of these people under the line, those are our people, Mom. Those are our people, Mama Izzo. They are not improving. I like this person who's gone to very many sessions and still I don't think he knows where the basket is. I'm good with that one.
Yep.
I would be more down here though. That's where I would be. Okay, so that's the slope. Now, interpolation means inside the data. So if you work with this trainer on the average after about 13 sessions, with her, oops, trainer's a her. Didn't see that one coming.
This is a non-binary world.
Wow. Gender bias. Okay, you'll be able to shoot about 12 baskets in a row. So, yeah, I'm thinking that Mama Izzo and I would not fit this estimate.
I am very, very, very below average.
Yeah, I would be very below average. But on average, if the average person coming off the street were to work with this trainer, after 13 sessions with this trainer, the average person off the street should be able to shoot 12 baskets in a row.
Okay.
That's what interpolation means, because it's inside the data points, so there are data points above it, and there are data points below it, and we've got that nice line there. We good?
Yep.
Okay. Extrapolation. Extrapolation means extra data. So if you work with this trainer on average after about 18 sessions, you'll be able to shoot 16 baskets in a row. So if you notice, there are no data points up here, yes? No data points up here, so we are just guessing based on the general trend of this graph that that's about where we would land if we kept working with this person. Now, is that for sure where we'll land? Probably not. As we said, there are people who are going to be below average, there are going to be people who are above average, and it's possible that maybe it tapers off. Like, after a certain number of sessions, we can't improve you anymore. You're done.
So it's sort of like a hypothesis in science, right?
Yes, very much like a hypothesis in science. It's guesswork. It would probably then need to be proven. More statistics would need to be done on it, but it is a good guess as to what might happen.
Based on what
Based on the trend. Based on the average trend, what's happening. Okay. And then, of course, we have outliers. We would be outliers. We would very much be outliers. These are outside the graph. This is a person that is not near the rest of the points and far from the regression line. This person is unusual. I'm unusual. Definitely unusual. I'm right there for it.
Except I'd be unusual. I'd be an outlier on the bottom.
I would definitely be an outlier on the bottom. Yep. Yeah, I would not be that high. Basketball is the one with the orange ball, right?
Yes.
Okay, just making sure. Just making sure. Okay. So, how good are these guesses? That's the next question we have to worry about. Well, also, why is it important? Because for a trainer, I feel like not as important. I feel like most trainers would not actually do the statistics to figure this out. Particularly if they want to do more than just shoot baskets. I feel like basketball has more things involved. They run in basketball, right?
Sometimes.
I feel like there's running involved.
Sometimes there's tripping and falling, though.
Oh, I would do that. Yep. Okay.
But this would be important if you weren't talking about trainers, right? This would be important like if you were a teacher and you had to explain your statistics with how well your students do on tests, right?
Yes, absolutely. And that is, we go back to this. Do you remember these clouds?
I do.
Yes. Doctors, television shows. So television shows, will your favorite show have another season? Very important information, particularly when you really care about the television show. And so for ratings, this will determine people's jobs, whether they have jobs, whether they don't have jobs, all that good stuff. Same thing for sports, game versus number of points. Will your favorite player be able to continue? Will they be retired? For businesses, will the business survive or will the farm survive? So farms and businesses have been known to at least do a somewhat progression, I believe. Didn't they do that in Chicken Run? I feel like they did that in the movie Chicken Run, figured out who had eggs and who didn't lay eggs.
Yes, because the ones that weren't laying eggs were going to be made into Mrs. Tweedy's chicken pies.
Yes, true statement. So statistics. Chicken egg production versus chicken pie production. Doctor's office, are you healthy? Like, that's important, I guess. And, of course, zombies, will you survive the pandemic? Very important. Yes, so these bivariate statistics actually end up being very important for some things, clearly not for trainers or for Grandma's Garden, but for other clouds, very important. The other question that I posed was, how do we know how accurate these statistics are, right?
Yes.
How accurate are the statistics? How accurate is that regression line? Yeah, that's the big question. And that is what we will be doing next episode. Yes, Squirrel, are you ready? Are you going to stay tuned for next episode?
She doesn't want to wait.
You don't want to wait? You are a very impatient squirrel, I noticed. But you're going to have to wait. The end.